are going to basically just revise for our test. And first thing first is let's talk a little bit about what is in your test. It's pretty easy to see. I hope you are looking at our Canvas site, and you've got essentially 4 sections, 2 chapters, and they're all about confidence intervals, right? And the first chapter 10 is proportion, single, and difference in 2 proportions. And chapter 11 is a single mean and a difference in 2 means. And they do share an awful lot of common attributes between the 2 different groups. The formula for getting the standard error is different when you do proportions than when you do means. I mean, that's a little difference. When you do chapter 10 in proportions, isn't it the magic Z-scores? And those Z-scores don't change no matter how big or small the data is. So for instance, the magic Z-score for 90%, anybody want to throw that one out? What's the magic Z-score for 90% confidence interval?
1.65.
Or 645, but 65 is fine. I wouldn't knock that one. When you do means and standard deviations, don't you? It takes a little bit more work.
Hey, Professor.
Yes.
Dane is in the waiting room.
Not in my. Oh, you're right. I didn't scroll up. Thank you. So when you're doing estimates and involves means, right? An estimate for a single mean or the difference, don't we use the magic t-scores? But they change, and that's why you need that table, the t-distribution table. And I think we've probably flogged that poor horse to death as well, because we've done lots of them. And that's what your 4 questions are going to be about. And all of these questions are going to be in a PDF. There is going to be no WebAssign associated with the next test. I've moved, I think I have anyway. I remember doing it, but maybe I forgot to save it. All homework has now been moved to midnight Monday. And that includes the extra credit. So if you never had a chance to do the extra credit, it's still open for you to do. And test, Zoom, the whole thing, don't cheat. You can use any notes you like. When you do the test on Tuesday, WebAssign will be closed. There won't be anything there to see. And Canvas will be closed except for the PDF where the test is, and the T distribution, the thing so you can find the T-scores, and what else? And the place to upload your work in. So I think we're used to the way the tests work now, nothing really special. The meeting will be the usual Zoom meeting, and so we'd like to see you. And one last thing, this is the 4th test. There is one more test to come. And we've got a good head start on it because we're already fighting our way through this one here. So we'll have 12 and 13, all the hypothesis test on. And when you do that test, the last test, test 5, some of you might have Monday off because that test will be due on Monday the 14th. And the reason for that is I only use the top 4 best tests. So if you've got some really good test scores from your first 4, you can choose not to do the 5th test and it won't affect your grade. So you might get a day off. Or you might decide just to do the test because you want practice at tests anyway. And that's totally fine as well. If you've got a missing test or a very bad test and one that you really think you could do much better on, then you definitely should do test 5. So that's the big picture. Pretty much everything is typical the way it should be. Have we got any questions about the test first, and then we'll open it up to questions about other stuff later. Right, Melissa, you do not take, sorry, hold on a sec. Melissa, you do not do anything right now. You are driving, young lady. I do not want to see your hands leave that steering wheel for anything. You are listening. That is your job. I lose so many students every year with them doing that. So you're not going to crash into anything. There, that was me being serious. Sorry now, what was your question?
I was is the final exam gonna be like the tests that we did?
Yeah, the final exam's going to be a little bit different and a little bit the same. It's a bit most. They're going to be questions that are on a PDF, and they're going to be questions from WebAssign. And that's just because some questions need salt, right? Some you need to go in and get the data, you know, like the hypothesis test and the p-value and all that good stuff, right?
So questions with salt.
Yeah, so some of the questions you'll do in salt and some of the questions you will do in PDF form. So that's going to be a little bit different. The second thing that's going to be a little bit different is that the structure of the PDF questions will be a little bit in two parts. The first part will be multiple choice. So what I do there is I put all those questions where, and a lot of them are just coming straight out of the homework and the test, where they ask you a question and there's 4 things and you pick the right answer, right? A, B, C, D. So I tend to put all those questions right at the front. You know, you just pick a letter and it's A, B, C, or D and you're gone. So that would be a little bit different. So you've not seen multiple choice, but that's what you'll get in your PDF. And then the section 2 of your PDF will look very like your test questions, same kind of things, right? Different questions, of course, but same kind of things. And that's the PDF done. And then you've got WebAssign stuff where the questions where you need to use salt, essentially, right? The ones where you would go in and use salt to get answers. That's where I put those guys. Any other questions? Okay, have we got questions about any of these 4 topics? Because you are going to get 4 test questions, 1 from each of these 4 sections. So I'm going to give you a question about single and so on. Question?
Yes, and this is Nakia.
Okay.
In the homework, let me make sure I know what topic it is. Let me go to the top. The estimating the value of a single proportion. I'm in 10B. I skipped. I would like to go through the process again because sometimes I do it and I get the right answer the first time, and then other times I do it and I keep getting the wrong answer. And the one,
and you don't know what you're doing different,
right? And then also number 6, where you just use salt to find the intervals. I have no clue how to use that.
Don't use salt. I know that the WebAssign says does it, but don't.
Okay, can we go over
Sure.
that a little more? And they just give you the information, the sample and the number of patients, and then it says find the interval. I don't know. I was confused.
Okay, so I could do question 6, or I could just make up one because they're pretty easy to make up as well. Do you have question 6 handy? If that was the one.
Yes,
was
I do. Yes, sir.
Right. So what was the information that they gave you?
Sorry, it's hard for me to maneuver all my.
I know how that works with all the windows I've got on.
It says, suppose a new treatment for a certain disease is given to a sample of 190 patients. The treatment was successful for 159 of the patients.
So it's 159 out of, what was that bottom number again?
190.
Okay, gotcha.
And
that's
then it says calculate a 98% confidence interval for the proportion.
98%, but we can live with it, right? So we're doing a 98% confidence interval based on this data. So the formula for a single proportion is p hat plus or minus the magic z-score, 98, it's a bit messy, but I'll do it, followed by the standard error of p hat. Right. Now, p hat is this guy. So I'm going to do 159 divided by 190, and I'm getting the answer 0.8368 plus or minus that magic z-score. So I guess I should look up what that magic z-score is for 98. And the magic.
If you're not sharing your screen.
I am not, sorry. I don't know where I'm probably looking at that screen. That's what I'm looking at. I was going to get the magic 98% there, but I can still get that with here. So in this story, success rate was 159 out of 190. That's a sample size of 190. We're going to get a 98% confidence interval, which uses this formula. The p-hat, which is this guy, is that ugly decimal, plus or minus. The 98 guy is 2.326, at least that's what I'm reading. And the standard error here is p-hat, q-hat over n. And I guess I should have done that separately, but too late now. So it's 0.8368, give or take 2.326 times this fella. And this fella is using these numbers here. So here we go. So it's a square root of p-hat, which is 0.8368, times q-hat, which is what you get if you take that away from 1. So that's 0.1632, and divided by the sample size, which was 190. And I get the answer 0.0268. So I now have 0.8368, give or take what you get when you multiply those together. So I've got this guy, so I'll just multiply the 2.326, and I am now looking at 0.0624. And if you subtract that, so 0.8368 subtract 0.0624, we get nothing 0.7744. And if we add it, 0.8368, add that guy, we get this fella. Now, I don't know what the question's accuracy is, but I have noticed from other students that WebAssign could be really pernickety about the rounded off values. So right now, these are 4 decimal places, but it might be that they only want the answer to 2, in which case that would be my answer. They might have wanted it to 3, in which case that would have been my answer. So sometimes you do it correctly, and it's just you didn't round off the way they wanted. And I have noticed something that's even more insidious. I did all these calculations to 3 or 4 decimal places. I've got a nasty feeling that they are doing this on software where they're probably working to 12 decimal places, and they only round off right at the end. Now, you might not think that will make a big difference, but it can make a difference. I've seen examples where their answer ended up being those 2 numbers. Now, you notice that they are essentially the same numbers, just a little bit of rounding off issues. If they want an answer to 3 decimal places, it's just safer to do everything to like 5 or 6, just so you don't get nailed at the end because the rounded off a little bit differently. It's very easy when you do a calculation to 4 decimal places. The final answer isn't good to 4, it's only good to 3, right? Because of rounding off issues. So just be a little bit careful about that. So you might be getting the right answer, but WebAssign is saying, no, I want this, and you gave that. And that could be the issue. The good news is, since you're doing this by hand, and I will see all this working, I will be able to tell whether or not you were doing it correctly, and you won't get a big cross and 0 points. Unless it's really blatantly bad rounding off, you should get all the points. So I wonder if maybe that's what the issue was. Is this the kind of process you were using?
Yes, it is. And I think sometimes I do the rounding wrong, and sometimes I have trouble on my calculator with the square root piece of it, where I don't know. And then I work late too. So sometimes when I do it again in the morning, I get the right answer. But
So just tiredness kicking in. In my case, mistakes are old age, right? In your case, it's just tiredness. And in David's case, it's just because he's bored and he wants to do something different, right? 2 times 2 is 4 is so boring, right? Occasionally, you should just chuck in a 5 just to make it interesting. Don't know why I said that. I just picked on David because his picture is above yours, Nikia. Are we comfortable with that process? Right. Have we got another question? If not, I think I'll just pick a question from each of the 4 sections. That may be a good way of just summarizing what's going on.
I do have a question, and I'm assuming this isn't going to show up on the test, but it's in that same section. It's question 13. It's what is the confidence level as a % for a confidence interval computed a sample proportion plus or minus 2.61 times the standard error. So it wanted us to figure out the confidence interval, but I just don't know how you would. I just don't know how to work backwards that way, I guess.
Yeah, you're right. You wouldn't get a question like that, but you can work backwards. So I'm assuming you know, let's pretend I knew this fella here, right? So I've got 0.8368, right? I know that guy. I got a plus or minus. I know this guy, right? 0.0268, right? I don't know this guy. But you gave me an interval, right? And let's just say you gave me this interval here. This is how I would work backwards. If you look at this guy, him, and you subtract him and add him to this guy, what you will come up with is the numbers plus or minus, depending on which one you do, 6, 2, 4, right? So you take it away from this guy, you take it away from this guy, and this is the guy that you get. This guy is a margin of error. This fella times this guy is the margin of error as well. So that means Z star is this fella. And that ends up being 2.326 or thereabouts. And then you go and look at your table and you find out what confidence interval uses that Z score. And that way you know it's a 98. Suppose I did the same calculation and I got 1.96. What confidence interval was I using?
95. Okay, so I guess that was actually helpful, but I guess that didn't answer my question, because my question is 2.61 is the confidence interval they're looking for, and 2.61 doesn't exist on that table.
Then that's what I thought the question is. Now we'll show you the next one.
Yeah.
2.61, negative 2.61. If you find what percentage is between 2.61 and negative 2.61, and let's just say for argument's sake it ends up being 97%, you have done a 97% confidence interval. So you might say, well, how do I do that? That question you probably would have to use SALT on. Couldn't you go into SALT and do the two-tailed 2.61 minus 2.61, and it would tell you what the piece in the middle was, a between one? And that would come out, well, I'm saying 97, who knows what it is, right? It could be 92 for all I know, but that's what it would look like. Do you want to see that in SALT so you can kind of see what I'm talking about?
Yeah, will you?
Sure.
Thank you.
Let's see if I've got an open window with the guy in it. Is it here? No, okay, just take a few seconds. That guy and that guy. So what we're looking at is somebody told us what the Z score that you were using, and your job was to try and find out what kind of confidence interval would be using that Z score, right? So I'm almost there. I'm just loading up. Darn it, I've got Windows everywhere today. Let's pick Yeah, I'm just picking which one. Yeah, I'll pick this guy. I'm just picking 12A so that I can get a salt window. That's all I need. Of course, I picked one that doesn't have a salt window. Let's try one that does. Right, we got one here. Right, so go away. There we go. So what you're looking at, or should be looking at right now, is this salt window. Can you see that guy? Use salt. So I'm going to click on it, not for the reason that they had it. Normal distribution, 0 to 1. I'm going to do a between. And the Z-score that you were using was 2.61. So that is going to be a negative 2.61 all the way to a positive 2.61. And what that will tell me is that you are using a 99.095 confidence interval. I would probably call that a 99% one, but you know, if you want to round off to 2, it is. I think if I remember that question, don't they want something like 4 decimal places?
They wanted 2 decimal places.
Oh.
I was just totally guessing the whole time. So I got the 99, but.
So now you kind of know where it came from.
Yeah.
Imagine somebody in Scotland decided that they wanted to use a magic Z-score of -3. Oops, too many things. -3 to +3. So they just wanted the magic Z-score to be a nice number, right? Something that he could work with without too many decimals. Can you see that that would be a 99.73% confidence interval if you wanted to be really precise? Which is a very confident interval, right? I'd be pretty happy with that confidence interval. I'd be, in fact, 99.73% sure that the real answer was somewhere in that interval. One of the reasons we don't allow that is, can you imagine how messy it is if everybody just decided on what confidence interval they wanted to do? That's why I hate 98. Nobody does 98s except it seems this textbook. Okay, have we got any other questions? Otherwise, I'm just going to pick, as I said, one from each section, but we've already done one of the 3. Okay, let's do a between a confidence interval, right? And it's going to be between 2 proportions. So we are going to have Scots and Americans. And
will you share your screen again? Thank you.
Thank you. So I'm just creating a story from scratch here. So they conducted some samples. They wanted to see if there's any difference between Scottish and American adult males' opinion on soccer. And they asked Scotsmen, do you like watching soccer, right? Do you like what we would call football? And in Scotland, the answer came out as 82% of males said, yeah, I like watching games of soccer on TV. And they asked Americans the same thing, and the answer came out as 27%. So it's pretty obvious that there is a difference, but what we're going to do is test, is it statistically significant? Now, if those both samples were 1,000, would you agree that it'd be a miracle if it wasn't statistically significant, right? With a sample size of 1,000 and a difference that big, it's going to show, right? In fact, it'll probably show up with an interval that's really, really positive, which is what you're looking for if you want to prove one is bigger than the other, for instance. But let's just say that they decided to only ask a few people. So they randomly found 50 Scottish people and 40 Americans, and this is the result. So we may or may not end up with a significant result now because those values are small. Great. What is the test that you need to use to show that your samples are big enough to even do one of these tests? Can you remember it was to do with NP and NQ? What was the value for NP and NQ had to be valid?
10.
10. Do you know this one fails at? NQ is not 10. I believe it's 9. But let's pretend that we overlooked that little hiccup, right? But I can imagine homework question where they might ask you just that, you know, why shouldn't you use a confidence interval with this information? In a homework, in a test question, wouldn't you just simply say the sample size was too small? NP or NQ was less than 10. But back to this one, we're assuming that we can use it. So we have to set up some useful statistics. So I'm going to just write them down. The difference between them is pretty much the first thing I would look for. It's, in this case, it's a positive number. So it's 0.82, take away 0.27, and I'm looking at a 55%. Big difference. You might want to write this guy down if you cannot give me the answer right now. What is the formula for the standard error for the difference between two proportions?
I think it's S1 square over
That
N1.
is the formula for the difference between two means.
Oh,
the
okay.
difference between two proportions. So write it down in a card, difference between two proportions. Anybody want to tell me what the right one is for proportions?
P1 times Q1 over N1.
With little hats on it?
Yeah, with hats. Hats for all of these, and then P2, Q2 over N2.
And that ends up being 0.82, 0.18 over 50, and a 27, a 73 over 40. And when you're doing a test, it's really helpful for me to see what you were using, what numbers you were using, because it's very easy in the heat of the moment, isn't it, to maybe hit a button wrong here. You type in, instead of 0.18, I know, you type in 1.8 or whatever. If I can see that you're using it correctly, then you can certainly get most of the points if all that you've done is maybe hit the wrong button on a calculator. So right now I'm just putting in each of these values, and I may myself screw up. So if you see it, you shout. I get 0.08, say 9. So I'm doing that. Now we'll assume that this question had a 95% confidence interval, right? So they asked you to find a 95% confidence interval. So let's do that. For a 95%, it's P1 hat take away P2 hat, plus or minus the magic Z score for 95 times the standard error. Now I've already found that guy, 0.55. Does anybody know the magic Z score for 95%? And if you don't, that would probably be another card that you should write these guys down on. What is 95?
1.96.
Correct. And the standard error is 0.089. I will not give you a 98% confidence interval. I refuse to encourage bad things, right? So if you get one of these, well, not if, you are going to get one of these, it will be a 90, a 95, or a 99, right? That's the only 3 guys in town as far as I'm concerned. So I'm taking this guy and multiplying it by that, and I get 1.96, and it's going to be 0.089, and it ends up with 0.09 if you round it off, because 85 times 9, and this becomes 0.46 or 0.64. And I like percentages, so from 46% to 64%. So we can say that we are 95% confidence that the true difference between Scots and Americans liking football, soccer, is somewhere in the range 46 to 64%. Isn't this evidence to prove that Scots people like to watch soccer more than Americans? Why can I say that this is statistically correct, right? Statistically significant.
Professor Robertson?
Yes.
Did you say the 1.96 times the 0.089 equals 0.09?
I did.
That...
And did I screw up?
Okay. I don't know. I'm trying to see if I...
Oh, I did. Would you look at that?
Okay.
Do you see what I typed in? Now, 1.96 times 0.089 changes that guy to 0.55, give or take 0.17. So that's 0.38 and 0.72. So it's 38% to 72%. Now, if I had done everything that I've written down here and I was grading myself, do you know I would not have lost that many points? Can you see that the only thing I did was a very simple, I hit the wrong button on my calculator, right? It wasn't the process was wrong. It wasn't what I was doing was wrong. It was just careless. Right? Do you know what WebAssign does when you do that? Doesn't it give you a big cross and you get nothing out of 10? Which is one of the reasons I like doing PDFs. I can get to see you're working better. When you do questions on WebAssign and I ask you for working, some of you are not as good as showing me it all, in which case you could lose points. Right, so back to my answer, or the answer I was looking for. Why does this mean that it's statistically significant? What's special about both these intervals that would make it statistically significant? Cheyenne?
I was going to say, is it because it doesn't cover 0?
Correct. And isn't it also that they're both positive, which is another way of saying what you just said? Mm-hmm. And if they're both positive, doesn't that make the first guy bigger than the second guy? Mm-hmm. And so I can say it's statistically significant that Scots people like watching TV, football on TV more than Americans. If that interval was both negative, wouldn't it still be statistically significant? But wouldn't it mean that the first thing was less than the second thing? So that would mean Scots people watched soccer on TV less than Americans, right? And if it does have a 0, which is the third possibility, if your interval contains 0, isn't that not statistically significant? So I can imagine in a test question, I might say to you after A, B, and C, I might say, is this statistically significant, and justify your answer? And you would say something like, it's statistically significant that Scots people watch soccer more than Americans. And the reason for this is that the interval contains nothing but positive numbers. That would be the reasoning that you would add. Are we good on that question? Well, time has got the better of us because we only have 5 more minutes. So if you're doing a single mean one, oops, start again. Don't know where that symbol came from. When you're doing question 3, it's going to be X bar plus or minus a magic Z-score, say a 95. And the standard error is, you could do it, I'm trying to do 2 things at once. I am not good at rushing. It's X bar plus or minus 0.95 times, and the standard error for X bar. And so it's going to be X bar plus or minus this fella times. Can someone tell me the formula for the standard error of X bar?
S over square root of n.
Correct. And that's for a single mean. And that would be question 3. Question 4, it's the difference between 2 means, so it's that guy. Plus or minus, I'm saying a magic Z-score 95, but it could be 99 or 90. And the standard error is a different formula as well. So it would be x1 take away x2 plus or minus 0.95. And what is the standard error in Nikia? Because you wanted to do it the last time. What's the standard error for this one?
I'm assuming it's the S1 square over the square root of n, is it?
No, just put N1 there. Right.
N1, okay. And then plus
add
the S2 square over N2.
Correct. Great. All these formulas are really crucial. So you've got to make sure that you've written them down and they're easy to access and you know where they are. There's an extra hiccup that you don't have with the first 2 questions. The magic T-score depends on the data size, right? What n is, right? Now, if n is 28, you use degrees of freedom 27. So when you look up the table, it's row 27 and then you read down. What happens if the degrees of freedom are not in your list? Like it's 132 or 607 or some weird number like that. Where do you look? What row do you look for if your degrees of freedom are not on your table? What do you do?
Whichever it's closest to.
Go for the closest, right? Typically. Now, when there are 2 different sample sizes, an N1 and an N2, and N1 is 50 and N2 is 300, just to be really awkward. What is the degree of freedom rule for this fella?
49.
And the rule is pick the small one and take one away from it. And that's a very crude rule of thumb, but it works. And you don't want to do the weird formula that you might find in the textbook, because even doing that would probably give you headaches.
I have a question.
Yes, Elena.
So if you can't find the degree of freedom on the table, do you round up or round down? Because I forget.
The best place actually is to round down.
Okay.
But I will accept a round to the nearest. There's a little bit of flexibility there, but I would just say round down would be the safest. And the reason why it's the safest is it makes the t-value bigger than it might need to be, but that's safer than smaller than it should be. So if you want a rule, just go to the next number down, and that's totally fine, and that'll work. And the reason I say that there's some flexibility is, suppose the degrees of freedom end up being 99. Would you agree that you probably should use 100, because it's virtually 100 anyway? That's not a hard and fast rule, but in practice you have to be a little bit generous about your rules.
I also